Hello and welcome to my video, 3C people. I'm going to try to get through this one pretty quickly today because we're not going to be doing a whole lot of math calculations. We're just going to be looking at some questions and trying to figure out which mathematical tool I'm going to be using. So today I'm going to give you a bit of a gift. I'm going to give you a mathematical toolkit. Now, on this sheet is all of the formulas that we have used so far, and we're going to talk about how we know which one we're going to use. And so some of these things I've given you 2 or 3 different times now, but we're just going to be talking about it, and hopefully this won't drag on near as long as the last video. I apologize for the 20-minute video. So our topic today, selecting strategies, and our goal, I know that there are various ways to solve for sides and angles in triangles, and I can select the best strategy for the situation at hand. So here's our trigonometry toolkit. The first 2 things aren't directly trigonometry, they're more just geometry. One is the Pythagorean theorem. We've already gone over Pythagorean theorem. You may use the Pythagorean theorem anytime you have a right triangle and you have 2 side lengths and you're looking for the third side. Pythagorean theorem is completely useless with angles, but it is quite perfectly acceptable to use it to find a side length if you know 2 sides. So if you know 2 sides of a right triangle, you can always find the third side with Pythagorean theorem. So this is Pythagorean theorem. Sum of angles theorem. If you know any angles, if you know 2 angles of any triangle, you can always find the third by subtracting the other from 180. We've talked about this a little bit, but I'm going to highlight it here again, and then we can find this one by doing 180 subtract 43 subtract 82. Now, the new things, well, not quite new, we did primary trig ratios last year, but if you have a right triangle and there's 2 different situations you use this. First of all, and I'm going to get out that highlighter again. You knew this was coming, right? I highlight this every time. A right triangle, even though it's in capitals. Primary trig ratios have to have a right angle. You cannot use it without the right angle. So if you have 2 sides, you can find an angle in the triangle. So any of these 2 sides, you can use sine, cos, or tan in this ratio form to find an angle. Or if you have an angle and a side, then you can find any other side. Remember, you need 2 sides for Pythagorean theorem. You only need 1 side and an angle for primary trig ratios. And lastly, we've got the 2 different laws down here. We've got Sine Law. If you have a non-right triangle with an angle side pair having known values, so here's an angle side pair with known values, and you need another angle if you're finding a side, or down here we have an angle side pair and a side if I'm finding an angle. Okay? And we usually, if you're finding an angle, you use the one with the angle on top. If you're finding a side, you use the one with the side on the top. Now over here for cosine law, if you have a non-right triangle with all 3 sides that have known values on them, look, they all have numbers. Okay, all of these 3 things have numbers. Then you're going to find an angle, any angle at all. So in this case, angle A is marked. We could find angle A. You can using this one. Or if you have a non-right triangle that has the Pac-Man situation, where you have 2 sides and the angle chomping down on the angle, then you can find this side over here by using this sine law, or sorry, cosine law. All right, let's get rid of those purple marks off of here. Now, going over, we're just going to look at all of these triangles and decide, which mathematical tool are we going to use? So the first one, I have a right angle triangle. When I have a right angle triangle, I need to think either primary trig ratios or Pythagorean theorem. Now in this case, I don't have 2 side lengths. You have to have 2 side lengths for Pythagorean theorem, so this is one of the primary trig ratios. So I'm going to look at the primary trig ratios. Remember, I have to circle the angle and think of the sides. So the sides that are here that I need information about, this side is adjacent and this side is hypotenuse. Remember SOHCAHTOA? SOHCAHTOA? It's been a couple days since we did that, but SOHCAHTOA is still handy. We want an A and an H, so I look here and there's the A and the H. So it's cos that we need to use. We need to use the cosine ratio. Not the cosine law, the cosine ratio. Adjacent over hypotenuse, this one here. Now over here, first of all, the first thing I'm going to look for is a right angle. This one does not have a right angle. So I know if it doesn't have a right angle, I got two choices. I got sine law or cosine law. Now sine law needs an angle side pair. So let's see, do I have an angle side pair? There's an angle and there's the side across from it. So there's our winner, ladies and gentlemen. We have a winner. And what I'm going to do with this one, since the other piece of information I have on this diagram is an angle, what I would be doing here is finding a side. Okay, so this is cosine law, mostly because we have an angle side pair. We have an angle side pair. Moving right along, let's look at the next one. Remember, what's the first question you ask yourself? Is there a right angle in this triangle? Well, is there a right angle in this triangle, ladies and gentlemen? It certainly does not look like it, so there's no right angle. So we have two choices. Once again, we can use the sine law or the cosine law, but which one is it? Which one will it be? Well, sine law needs an angle side pair. So here's an angle, but we don't have the opposite side. That's what we're being asked to find. It does not have a known value on it. And there's no other angles. So since there's no angle side pair, we cannot use sine law. So I'm going to take my red pen and say, nope, can't use sine law. Is it cosine law? Does it have all three sides? No. Does it have a Pac-Man situation? Well, we've got a side and a side with an angle between it. This is definitely cosine law or the Pac-Man situation that we talked about before. So we would use cosine law. Most specifically, this is cosine law to find a side. So this one will be the one that goes c squared equals a squared plus b squared minus 2ab cos c. Now this one over here, it's not marked, but that is supposed to be a right angle in there. So we're either looking at Pythagorean Theorem or primary trig ratios. So what are we being asked to find? Well, I'm going to take my pink and put a dot on the x. And that x is an angle. So we're being asked to find an angle, which means that I cannot use Pythagorean Theorem. Pythagorean Theorem has nothing to do with angles. So this is one of so, ka, or toa. And is it so, is it ka, or is it toa? I don't know. Let's have a look. So let's circle the x, ladies and gentlemen, and now let's label the sides. So the side directly across the triangle from the x is called the opposite side. The side that touches the x is called the adjacent, and if we look across the triangle from the right angle, we find the hypotenuse. Now, the two sides that have numbers on it are the sides labelled with the O and the A. So I'm just going to go O and A on my SOHCAHTOA. Well, that looks like the tangent ratio, ladies and gentlemen. This is going to be tan. And we know that tan equals opposite over adjacent. So if I wanted to solve for this, I would have to put 9 over 10. And that would be solving for angle x in there. I'm not going to complete this. I'm just talking about it, ladies and gentlemen. So this is tan. Moving right along, I've got 6 more situations. Now, it would be a good idea at this point if you were to pause this video and try to come up with what these 6 situations are going to be. So please pause the video now. I said now. Pause the video now. Okay, now if you pause the video, I'm going to very quickly go through what these are. I went through it a little bit slower for the first 6, but now I'm going to go through these ones rather speedily. Hopefully you've already given them some thought, so I'm just going to be reinforcing what you were thinking about. So let's see how fast I can get through these. So in the first one, the first thing that I notice is that there is a right angle in here. So right angle suggests primary trig ratios or Pythagorean theorem. Since there is only one side given, it cannot be Pythagorean theorem. I need 2 sides for Pythagorean theorem. I've also got an angle, and Pythagorean theorem has nothing to do with angles. So I'm going to circle that angle so that I can figure out whether I have a ka or a toa. So now I label the sides. This is opposite, this is adjacent, this is hypotenuse. And when I look at it, I do not need the hypotenuse, so it's the OA that is the issue. And when we're looking at OA, this, ladies and gentlemen, is the tan ratio. Going to the next one, it is not a right angle, so that suggests to me either one of sine law or cosine law. Now remember, the 2 situations for cosine law are the Pac-Man situation and the all 3 sides situation. This one does not have all 3 sides, but if we look rather closely at it, we see the Pac-Man situation. There is this big wide open mouth of Pac-Man gobbling up 123 degrees of an angle. So this is in fact the cosine law situation, and more specifically it's this one where we're finding an angle where we say a squared equals b no, let's use it the way that we've been doing it. C squared equals a squared plus b squared minus 2ab cos c, where a and b are these 2 sides, does not matter what order they're in. Going down here, over here we have a right angle triangle, and we don't have 2 sides with given values, so it is not Pythagorean theorem. So it must be one of the 3, so ka and toa. So I'm going to circle the angle that I'm given and label the sides. This side is opposite across, this side is adjacent, and across from the right angle we have the hypotenuse. The 2 sides that have information on it or information required are O and H, which is right here, so this is the sine ratio. The next one has all 3 sides given, and this is a non-right triangle. This is immediately, whoops, not sine. My hand has a mind of its own. This is the cosine law. This is cos law, and is the cos law that finds the angle, which would be cos theta, or cos c, equals a squared plus b squared minus c squared over 2ab. 2 more to go, ladies and gentlemen. Let's see how quickly I can say them. It is a right triangle. We're talking about an angle, so it can't possibly be Pythagorean theorem. So when I look at the sides, this is opposite, this is adjacent, this is hypotenuse. It's the A and the H that have the information on it. The O is of complete it's not used to us at all. So if we're looking at ka toa, we're looking at the AH situation. That is the cos ratio. And the last situation here, this is a non-right triangle, so we immediately think, is it sine law or is it cosine law? I don't know. You tell me. Is it sine law or is it cosine law? Well, remember the cosine law, we either need all 3 sides or we need a Pac-Man situation. Do we have all 3 sides or a Pac-Man situation in this case? No, we do not have all 3 sides. We do not have a Pac-Man situation. So that leaves us thinking that perhaps it's sine law. And remember, in sine law, we need a side angle pair. Here's a side and here's the angle across from it. We have a sine angle pair, ladies and gentlemen. And one other piece of information, which means that since we have a side angle pair and one other piece of information, the winner, ladies and gentlemen, is the sine law because of the side angle pair. And that brings us right to the 15-minute mark, and we are done. Goodbye, good day, end of unit, study hard for the test.